Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMathInstruction. Today, we're going to be doing Unit 6, Lesson number 5 on factoring by grouping. Now, so far you've learned three major factoring techniques. One, probably the most important, is factoring out a GCF from a polynomial. The second type of factoring technique was the difference of perfect squares, which relied upon your knowledge of conjugate pairs and how they multiply. And then the last one was a guess and check scheme that we used in order to factor trinomials. This last factoring technique is very, very specialized, but you've been working towards it for a couple of years, even though you probably didn't know it. And it's known as factoring by grouping. Let's jump right into an exercise that gets us prepared to do this type of factoring. All right, exercise 1. Factor a binomial common factor, this is interesting, a binomial, two terms, common factor, out of each of the following expressions. Write your final expression as a product of two binomials. So take a look at this first one. You've been doing this for a number of years, but notice that the 2x plus 1 is a common factor in both of these terms. Now, to me, this is really no different than looking at something like this. Right? If we look at something like this, we can easily see the y, and we simply factor the y out, and we're left with x plus 7. We have exactly the same kind of scenario here. Let me just put a line here, in that I'm going to factor that 2x plus 1 out, and then of course that was multiplying an x, and it was multiplying a 7, and that's it. This is the product of two binomials, right? A binomial and a binomial. Very similar here. I see an x minus 2 and an x minus 2. So I can factor an x minus 2 out, leaving me with a 5x minus 4. And again, we have the product of two binomials. Now these can become more challenging, let's say, when we take a look at something like this. Now, it's no challenge there. We've got x minus 7, but then we're multiplying it by x plus 5. I'm going to keep that in parentheses for right now. Plus, that's this guy, x plus 1. Now, in this case, the parentheses that are sort of inside this larger parentheses, these two and these two, aren't doing anything, right? We're not distributing anything, and because addition is commutative and associative, I can get rid of those parentheses, rewrite it like this, and then I won't write out all the steps, but we could swing a bunch of things around, and we'd have an x and a 2x, then we'd have a 5 and a 1, and we'd have plus 6. All right, so that's pretty easy. The hardest ones like this, as you've seen before, are ones that involve a subtraction right here. Let's take a look at why that's a little bit tough. If I pull that x plus 4 out, right, I'm going to keep with this parentheses business. Well, that x plus 4 was multiplying 2x plus 8, subtraction, but it was also multiplying x minus 2. And of course, here's where we really have to watch ourselves, because in this case, these parentheses aren't doing anything. So I'm going to remove them, 2x plus 8. But in this case, we have to distribute a subtraction or a multiplication by negative 1. And that's very, very important because that negative and that negative become that positive. But once I have that, then it's pretty easy. 2x minus x is x, and 8 plus 2 is 10. There's that product of two binomials again. So you've been doing this kind of factoring where the GCF is not a monomial, but a binomial, since Algebra 1, and it's not too bad. But it's going to serve the basis of factoring by grouping. So pause the video now and write down anything you need to. All right, let's clear out the text. So let's take a look at exercise 2. Now, exercise 2 is very, very similar to what we just did, but I want to emphasize something. We never want to lose the fact of something very, very important. When we do these kind of manipulations, when we're using real number properties, and we're going to take a look at which real number properties we're using in just a second, but when we do that, we are always writing expressions, not equations, but expressions that are equivalent, all right? And we want to test that equivalency. So what I'd like you to do, since we did exercise 1 together, is I'd like you to do the first part of the problem. Write this expression as the equivalent product of binomials, and then we'll test that equivalency just with the value x equals 2. So pause the video now and do what we did in exercise 1 to that expression. All right, let's do it. Well, the common binomial term, let me just kind of get rid of that line. The common binomial term that we have is this x plus 3 and this x plus 3. So I'm going to factor that out, and I'm going to be left with x minus 4, right here, plus, no need to put this in parentheses, 5. Now again, there's no subtraction going on here. Well, I mean, I guess it's x minus 4. But these parentheses, again, are doing nothing. So I can remove them, right? They're not telling me to distribute anything. Let me put a little subtraction sign there. So now negative 4 and positive 5 give me x plus 1. So hopefully you got x plus 3 times x plus 1. Now again, the idea is for every value of x for which this expression is defined, and that's actually all values, all real numbers, that more complicated expression, right, this one right up here, and the less complicated one down here should be giving me the same value for every value of x, but we're going to just test it with x equals 2. And let's test my original. So I'm just going to take 2 and I'm going to kind of plug it in and see what I get. Right, so I get 2 plus 3 times 2 minus 4 plus 5 times 2 plus 3. Now what is this equal? Well, we got to be careful with our order of operations. Do what's in the parentheses first. 2 plus 3 is 5. 2 minus 4, watch out, that's negative 2. Here we'll have 5 times, well, I guess 5. Now let's do the multiplication. 5 times negative 2 is 10. And of course 5 times 5 is 25. And that all is equal to 15. So let's now take a look at our factored form. Maybe put out little dots there. So now I'm going to take that x equals 2 and I'm going to plug it in here. So let's take a look. I've got 2 plus 3 in the first parentheses and 2 plus 1 in the second. 2 plus 3 is 5. 2 plus 1 is 3. And of course, 5 times 3 is 15. All right. Now, I mean, obviously, that check does not mean that these two are equivalent. What it does mean is they have the same value when x equals 2 is substituted in. But it is a good proof that we've done something right. If we had put x equals 2 in and gotten two different values, then we would know that we had simplified that more complicated expression incorrectly. So keep that in mind. If you're ever wondering whether you've simplified an algebraic expression correctly, pick a value of x, make it easy on yourself, substitute it into the original and the simplified version, and see if they give you the same value. Okay, pause the video now and write down anything you need to. Okay, I'm going to get rid of the text. I'm going to try to get rid of the text. All right, now I would like to take a moment and look at factoring by grouping. And you might say, well, I don't think we've factored by grouping yet. I completely agree. But this first exercise on factoring by grouping, exercise number 3, actually shows us how it's done and then asks us to justify each step using a real number property. So let's take a look. And again, I'll explain the technique of factoring by grouping a lot more. But let's say that we've got this. And we take those first two terms and we put them in parentheses. And we take the second two terms and we put them in parentheses. Which one of these 3 real number properties allows us to group the addition and subtraction like that? Because normally we should do this, then minus this, get a result, then add this, get a result, then subtract this. But I'm saying, hey, look, I'm going to group these two together, and I'm going to group those two together. What allows us to do that? Think for a minute. All right, that is the associative property. So the associative property tells me that if I've got addition / subtraction, I can kind of group it the way that I want. That's the way I look at the associative property. Now the next thing that happened was we took this binomial and we factored out of 2x squared, and we took this binomial and we factored out of 5. What allows us to do that? All right, that is the distributive property. Oh, we like the distributive property. And finally, our final step, we took this x minus 3 and this x minus 3, we factored it out, and we were then left with this 2x squared plus 5. Well, what justifies that? Now, if you put down the commutative property because you thought we had to use all three, well, that's not math. This is, again, the distributive property. It's interesting because most factoring really relies on the distributive property for all of its justification. Truly so. Although we tend to be using the distributive property sort of in the reverse order. So we are unmultiplying, if you will. Okay, well, in a moment we're going to go through and we're going to really dig into how to factor by grouping. But pause the video now and write down anything you need to. Glasses were slipping. All right, let's clear out the text and keep going. Let's see how this is done. Now, factoring by grouping is a very specialized type of factoring. Doesn't always work, just like difference of perfect squares doesn't always work. Okay, but here's how you do it. Okay, let's take a look at this first exercise. What we're going to do is something similar to what we did last time. I am going to group these first two terms together, and I'm going to group these second two terms together. Notice how I put a plus there? You don't absolutely need to do that, but either that or you're going to have to put a minus and then factor it out. Now what we're going to do is we're going to look at this first binomial pair, and we're going to factor out a GCF. And what we can factor out of both of those is an x squared. Don't worry about that pair at all, right? And then what do we have? Well, when we factor out an x squared there, we have a 3x. And when we factor out an x squared there, we have a positive 2. Now, what can we factor out here? Well, here again, we're going to look for a GCF, and we've got a negative 27x and a negative 18. Now, the number that goes into both 27 and 18 is 9, okay? And we could certainly factor a 9 out, all right? And it would look like this. Now, I'm going to go back and I'm going to change this, so don't write this down yet. I could factor a 9 out, but notice this binomial and this binomial are not the same. Okay, this could be the trickiest thing about factoring by grouping. Almost always, I'm going to want to factor out, if possible, I'm going to want to factor out a negative. Now, think about this for a second. If I factor out a negative 9, then I would have to have a positive 3x inside of here for a negative 9 times positive 3 to be a negative 27. Likewise, I'd have to have a positive 2 here for a negative 9 times positive 2 to be a negative 18. Now, the reason that that is so good is that now we're back to exercise 1, right? We just want to factor that 3x plus 2 out. So when we factor the 3x plus 2 out, we are then left with an x squared here and a minus 9 here. Now take a look at this though. They ask us to completely factor, which means I can now break this x squared minus 9 into x minus 3 times x plus 3. Very often, when you do factoring by grouping, there is a final difference of perfect squares factoring that you can do. Not always, but sometimes. Okay? We also don't always factor out a negative. Okay, and we'll see that in a variety of situations too. Sometimes we get to a point where we factored out that GCF of a binomial, this thing, and we can't factor any more. Okay, so let's do another one. This next one is also going to have a negative that we factor out. So we're going to look at these two. I'm not going to even put the parentheses up at this point. I'm going to look at them, and I can factor an x squared out. Oh, but I can also factor a 9 out, right? Because 9 goes into both 18 and 9 and x squared. So what do I have left? Well, on this one, I'm just going to have a 2x, right? Because 2x times 9x squared is 18x cubed. We have to be very careful here. I also will have a plus 1, because 9x squared times 1 is 9x squared. Now remember, whatever I factor out of this thing, I want to also have a 2x plus 1 sitting here. And to do that, I would have to factor out a negative 1. But do you see that? If I multiply a negative 1 back through, it would give me the negative 2x minus 1. I'm not actually going to multiply a negative 1 back through because then that would defeat the purpose. But now I can factor that 2x plus 1 out, and I'll be left with 9x squared minus 1. Again, sometimes at this point we're done. Sometimes we're just done. There's nothing we can do. But yet again, in this case, that binomial is the difference of perfect squares. And it can be factored as 3x plus 1 and 3x minus 1. There we go. It's kind of cool. All right, let's take a look at a couple where you don't have to factor the negative out. Now, maybe we should have started with those, I don't know. But it's actually more common, especially when you get assessed on this, that you'd have to factor a negative out, because very often you then follow up with factoring the difference of perfect squares. The only way you're going to get the difference of perfect squares is if you have a negative sitting there. But let's take a look at the next one. All right, we look at these first two terms. We notice an x to the fifth and an x to the third. That means the best I can do is an x to the third. That's it. Now, what will I be left with? Well, on the first term, an x squared, right? Because x to the third times x squared is x to the fifth. And then on the second term, a positive 4. Okay, now we look at these two terms. No need to factor out a negative now. These are both positive. All right? And if I factor out a 2, I'll be left with x squared plus 4. And that's great, because the x squared plus 4 is common. So now I'm back to exercise 1. And then I've got x cubed plus 2. Both of these are what are known as prime, meaning that you cannot factor them any more than that. That's it. Now you might think, sure I can. X squared plus 4 is x plus 2 times x plus 2. But unfortunately it's not. X plus 2 times x plus 2, you'd have to FOIL out and you'd have like a center term. And x cubed plus 2, that's even worse. All right? So those are both prime, and we're done. Why don't you try letter D? Okay? Take a moment and try to factor letter D by grouping. All right, let's go through it. Again, looking at the first two terms, I see that I can factor out an x squared. But I can also factor out a 5. All right, that will leave me with an x, right? 5 times x squared times x will be 5x cubed. And it will leave me with a 2, right? 2 times 5x squared is 10x squared. I look at the second binomial pair, and I can factor out a 20. And that'll leave me with x plus 2. All right, great, I've got x plus 2. And 5x squared plus 20. Now, is there anything else I can factor there? Did you stop there? Maybe. But I can actually pull a 5 out of this. Now, if we've got a numerical GCF, it tends to be written down first. So I'm just pulling that 5 all the way out here. And then I'd have x squared plus 4. Again, everything there now is prime. No way to factor any of that. All right, this is really kind of a cool factoring technique. Again, it doesn't always work. I mean, you've got to have 4 terms. It's got to have 4 terms. That first binomial pair has to have a GCF. The second binomial pair has to have a GCF. And when you factor those GCFs out, then you have to be left with a common binomial GCF. All right, so there's a lot of things that have to go right for this type of factoring to work. Okay, pause the video now and write down anything you need to. Okay, clearing out the text and moving on. All right, now sometimes these can get a little tricky, so I thought I'd throw one out that's A's, B's, X's. Exercise 5. Consider the expression x squared plus AB minus AX minus BX. Letter A asks, how can you rewrite the expression so that the first two terms share a common factor? Because right now, x squared and A times B, they don't share a common factor. So how could you rewrite it so that they share a common factor? Well, the answer is lots of different ways. Lots and lots of different ways. In fact, if I rewrite it as x squared minus AX plus AB minus BX, well, now these do have a common factor, right? They have a common factor of x. So let's do it. Let's take this guy, now that we've rewritten it, and write it as an equivalent product of binomials. Pause the video now and see if you can do this. Okay, this is actually pretty tricky, because once I factor that x out of the first term and I'm left with x minus a, the tendency would be to factor a b out of the second term and be left with a minus x. Now, these guys are close, but they're not the same thing, right? That's kind of like 3 minus 7 versus 7 minus 3. They're very, very common, but they're not the same, right? This is negative 4, this is positive 4. So we don't quite have it. We don't quite have it. Let's try this. Let's try that whole factor out a negative thing. What if we factored out a negative b? If we factored that out, now this is tricky, then we would have to have a negative a there, right? Because then negative b times negative a would be positive ab, and then we'd have to have plus x, right? Because negative b times positive x is negative bx. Okay, well now I feel more comfortable, but do you? Right? Negative a plus x is certainly the same as x minus a. And now we've got that common GCF. X minus a there, and then not much work here. X minus b there. All right, so these can get kind of tricky, and sometimes you have to try something, and if it doesn't quite work out, manipulate and try again. Pause the video, write down anything you need to. Okay, now I've been teaching math for a while, and I've been seeing people make mistakes with factoring by grouping quite a bit. So let's take a look in this final exercise at a mistake a student made. Okay? So they take this 4-term polynomial and they start to factor it using grouping. What I'd like you to do is try to figure out the mistake they made. Pause the video now. Okay. It wasn't so much that they made a mistake in their factoring by grouping, is the fact that you can't even use factoring by grouping. So they factored out a 2x squared, and that was fine. This is good. Then they factored out a 7, and this is good. But their mistake was that in order for factoring by grouping to work, after factoring out those GCFs, this term and this term must be the same. They must be the same. Okay, since they are not, factoring by grouping doesn't work. So you shouldn't push it, right? Maybe there's some other way to factor this. Okay, now I do like the last piece though. How can you tell that the factoring is incorrect? So one of the most frustrating things for me is when students misfactor and they just, they shouldn't do it, right? Not because they've made a mistake in the process of factoring, but because they really should be able to look, in my opinion, at this final answer and just think about it a little bit and go, that can't be right. So why is it, forget about all this stuff up here, why is it that I think, or how can you know that these two things can't be the same? How do you know that? All right, well, let's talk about it. Of course, the way that you can always know whether your factoring is correct is by beginning to multiply it back out. So if I was to multiply this back out, and let's say I do this sort of the double distribution method. So I've got 2x squared times 2x plus 8 plus 7 times 2x plus 8. My first term, 2x squared times 2x, is going to be 4x cubed. But that's all I should need to know this is wrong. My first term up here is 2x cubed. Down here I'm getting 4x cubed. Those can't be the same. Not to mention, if you did 7 times 8, forget about all the other things. 7 times 8, you'd get 56, but I'm only supposed to be getting 21, right? So you can tell that the factoring is incorrect by even just multiplying the two binomials out just a little. And you'll know that some of those terms in the original expression don't match up. Okay, pause the video now and think carefully about this. I really want you to be able to check your factoring, especially with things like grouping. All right, well, let me clear out the text now, and we will finish up the lesson. We'll wrap it up. So today what we did was we learned the fourth major type of factoring, and this really is going to round out all the types of factoring that you will need to know for this course. GCF factoring, the difference of perfect squares, trinomial guess and check, and factoring by grouping. All right? They really cover probably 98% of all type of factoring that kind of occurs in mathematical problems. So it's good to become fluent with all four types. For now, though, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.